In this video, we'll see how we can make use of assignment operators in programming language C++. First of all, the definition of assignment operators. We should remember that the assignment operators are binary. It means they require two operands, one on each side of the operator. This is the definition. A variable of any type, the same variable, and before this general assignment operator, and then any binary operator followed by any expression, mathematical expression, which evaluates to the same data type, which is the data type of var, this variable. It means both of them must have the same data type. If this is true, if this statement is true, if we follow this, we can convert it into a new kind of statement. Here the same variable name, then the binary operator which we used earlier. Immediately after that, we need to use the same operator here. So this becomes a new operator followed by the expression. That is to say, this becomes a new assignment operator. We should remember that the data types of variable and the expression must match, and this binop, whatever binary operator we used, must be legal to apply. It means, for example, this variable is of type float, it is a real number, or variable for real number, and this binary operator is left shift operator, and here we have written some floating point number, or maybe an integer. We know that the left shift operator does not apply to floating point numbers. So this statement means that it must be legal to apply. This is our responsibility. Now let us see a few examples, and this is correct. We can make use of more than one statements in C++, delimited by properly terminated by semicolon, statement terminator. So here this is the very common assignment operator. So x is assigned a value 5. So what will be the value of x? It will be 5. Next one is plus assign. So float type f equal to 5.3, and this would increase the value of f by 1.2. It means it will first make use of the current value of f, which is 5.3, add to it 1.2, the new value would be 6.5. Similarly, here it is an integer, x is an integer, so x current value is x minus 3, so x would become x minus 3. Next one is again the same value of f. I have reinitialized it, 5.3. So f would be equal to current value of f, which is 5.3 multiplied by 2, which comes out to be 10.6. This happens to be the division assign, divide and assign. So suppose 5 is f is 5. Here intentionally I have written 5. It looks like an integer, but it would be treated as a floating point number, real number. So internal representation will be as per floating point standard, and this is forward slash, that is the integer division. It used to be if numerator and denominator both are integer. So here f is floating point number, so this will be real division. And also I have intentionally written here, just to remind you, the 2 point, this will also be represented internally as a floating point number or real number. So result has to be 2.5. It should be. Here it is a modulus operator, sometimes remainder operator we call it, x equal to 5. So x would be divided by 2, that is the integer division, and remainder would be 1. So value of x has to be 1. Here it is bitwise end assign. So x is suppose 5, x bitwise end 2 would be 0. So new value of x would be 0. Here it is just like bitwise AND, it is bitwise OR. So value of x would be 7. This is bitwise exclusive OR assign. So what does it do? It takes the bitwise exclusive OR of x, current value of x, and 2. Here again, by coincidence, value comes out to be 7. And here this is left shift assign. So current value of x is, suppose we have initialized it to 5 again. Left shift it twice, it means 2-bit positions. The value would be 20. And here x is shifted towards right 2-bit positions. So first shift would result in 2, because 5 divided by 2, the quotient would be 2, because it would be real division, integer division, and then 2 again divided by 2, so output would be, or the value of x would become 1. I have made a small C++ program to demonstrate the usage. Say on the left hand side, I would be executing the program, and the right hand side, let me scroll it a bit, scroll it up a bit. So yeah, so that you can see the full code. We can write, as I told you, I could have written these two statements in single line to save space, but usually for sake of clarity, easy reading, I have written one statement per line. So let me scroll it up a bit so that you can see all statements. Yeah, x equal to 5. So we'll come back to this again. So let me execute it. You can see here, this is a simple one. Okay, so on the left hand side we have these statements. So this would print 5, simple. This statement f plus assign. So what should be the result? Result is 6.5, as we have discussed in the previous slide. Here it would be -3. Here in this, corresponding to this C out, the result would be 10.6. Now you can see here it prints 10.6. If you watch my corresponding videos on C language, in C it used to print by default 6 digits after decimal point, but in C++ it does not happen like this. It prints only those many digits which are significant. This C out would print 2.5. Accordingly, this is the remainder operator or mod operator, sometimes we call it. So 5% 2. So current value of x is 5, divided by 2. What is remainder? Remainder is 1, which is printed here. Here this comes out to be 0. It is printed 0 here. And here the value printed would be 7, as we have just seen. And here as well, so value printed would be 7. Okay, now let me scroll it up a bit so that we can see the following statements. So here let me start with this one. This is statement x equal to 5, shift 2-bit positions left. So the value would be 20, because 5 shifted towards left once would be multiplied by 2 once more. So 10 would be multiplied by 2, which becomes 20. Reinitialize x to 5 and shift it towards right 2-bit positions. So first shift results in 2, next shift results in 1. So this is 1. Now this statement I have written intentionally. What we can do is we can put the entire expression, that is the assignment, in you can say a parenthesis, pair of parentheses. So this value would be evaluated. So what would happen? Current value of x would be taken and 2 would be added to it, and it will be assigned a new value, that is 5 in this case, would be assigned to x. So value of x comes out here. It replaces, you can say somehow, it replaces this expression, and that value would be printed. So it is not essential to write these assignment operators, use assignment operators in separate line. We can write here as well. Okay, so this is the way we can make use of assignment operators in C++ programming language. That is all in this video. Thanks for watching.